Hi, I'm Anne-Marie, and I want to tell you a little bit about how to get started on squishy circuits, particularly if you have no experience with electronics. We're going to post a bunch of videos on our website, some that'll go into greater detail, even some of the calculations that are involved in squishy circuits. This talk, though, is really intended for someone who doesn't know much about electronics and wants to get started with themselves or with their kids building squishy circuits. So to get started, this is sort of the key to squishy circuits. On our website, we have two doughs that have been developed. One that's very salty and uses regular tap water. We dyed it purple. The color really has no relation. We just made it so it's easier to understand what's going on in your circuits. We'll call this our conductive dough. Conductive means it lets electricity pass through it. So it acts really like a wire. Now, if you know a bit about electronics, I should note that it's not really wire. It acts more like a wire with a resistor built in. And this will be important when we talk about LEDs. But for getting started, the key here is that this is conductive. Our second recipe has no salt in it. This we call our insulating dough. It uses sugar, and if you have access to distilled or deionized water, it'll be much more insulating. However, if you use tap water for both of the doughs, the purple one will still be more conductive than the one that is sugar-based, so you should be okay. You'll just notice that your lights might glow a little less brightly than they would if this was made using deionized or distilled water. And distilled water can usually be bought at drugstores or at grocery stores. Now, again, if you know a bit about electronics, I should note that this is not truly an insulating dough. It will allow some current to flow through it, particularly if you use tap water. But for the sake of getting started with circuits, we really can treat this as an insulator, and we are going to refer to it as an insulating dough. But we are aware that that's not completely true. So to make our simplest circuit, we need a few components. The first thing we need is a voltage source, a power source. We, here at St. Thomas, typically use a battery pack that has 4 AA batteries in it. Each AA battery is 1.5 volts, so this is a 6-volt battery source. Other people have taken squishy circuits and used them with 9-volt batteries, or even with 3-volt power sources. We've had the best luck with the 6 volts, or 4 AAs. You can typically buy a battery holder like this at any electronics hobby shop. I think we got this one at Radio Shack. You will notice that on the ends, we've attached little metal terminals. We crimped them on, squeezed them on. The whole point of that was to make more surface contact area for the wire to the dough. If you've played with Play-Doh before, over time you notice that the holes get a little bit bigger, the wire comes a little loose. Again, this is optional, but if you go to our website, we do show how to do this and also how to solder it on to make it an even stronger connection. So we need our battery pack. The other thing we need is something to happen with our circuit. I'm going to start with a light emitting diode. And if you look here, this is a light emitting diode, or LED, and it's a light source. One thing to note with an LED, when we build this circuit, you might notice that it doesn't light up at first. That's because an LED is directional. If you think of electricity as like water flowing through a waterfall, water will go down a waterfall, but it won't go up the waterfall. Similarly, in a circuit, the current runs from positive to negative, and the LED is directional. It's got a positive side and a negative side. If you put it in backwards, it's like asking a fish to swim up a waterfall. You have to make sure that you put it in the right way. So if your LED doesn't work at first, pull it out and switch it around. You'll notice that the LED has 2 little metal, we call them legs, sticking out of it. Typically, the short leg is the negative side and the large leg is the positive side. Okay, so to get started, we typically will make 2 wires out of our dough. And again, it doesn't matter what shape these are. I'm going to make 2 little snakes. And I'm going to plug in the black wire into one and the red wire into the other. Okay. Now a circuit, which is what current will run through, has to be closed. You have to have a closed path. Think of it like a track. You have to be able to run in a continuous loop. Right now, we can't run in a loop. And even though this battery pack is on, the current has nowhere to run to. So now I can close this loop with an LED. So again, I'm going to take the longer leg and put that into the lump that has the red wire attached to it, and the shorter leg, and attach that to the lump that has the black wire attached to it. And when I do that, you'll notice that it glows blue. Okay. We have a bunch of different LEDs, and in another video we'll talk about LEDs and what the colors mean and whether that changes your circuit at all. But for the moment, as long as you have a decent amount of dough here, you really can use any color, pretty much any color LED. Again, look at our website. We can suggest some of our favorite LED sources, but we also use ones that we randomly find laying around the lab. I'm going to take another piece of dough, and now notice if I take this dough and I make a bridge between the 2 lumps of Play-Doh, what happens? I'll notice the light turned off. If I pull it open again, the light goes on. If I stick it down and make a bridge, it turns off. What's happening is I'm creating essentially what we call a short circuit. You can think of electricity as lazy. It wants to take the path of least resistance. In this case, the path of least resistance is going through the purple dough. So if it doesn't have to go through the LED, it would rather just run through the dough. If you just make the conductive dough, there's a couple other things you can do with it. First off, you can add more LEDs to your circuit if you so choose. So make a little row of these here. And you can play with the shape of your circuit. You can also add other components, for example, a motor. Now, a motor is not, will work in either orientation you put it in. However, the direction will change. The direction it spins in will change. You'll notice that the motor has two wires coming out of it typically, or two little metal posts coming out of it. We've, in this case, soldered on leads again, just so that it attaches more easily to the dough. You don't have to do that, but you'll find it makes the circuit building quite a bit more easy. And there are instructions again on the website for that. And I also like to put either a little piece of tape or a piece of dough on the top of the motor so that we can see it spinning. Now I'm going to take each of the two legs and attach one to each of the two lumps of dough here. And you'll notice we now have a spinning motor. Another component that we found really popular are buzzers. And now when you buy a buzzer, you want to make sure that you buy one that has a low enough input voltage. So in this case, this one needs at least 4 volts. And with our 6-volt battery, we have enough there. If I plug in, again, typically if you buy these at most electronic shops, they'll have 2 wires coming out. One will be black, one will be red. Red is positive, black is negative. And you'll want to match the color of the wire on the buzzer with the color of the wire that is plugged into that lump of dough. So I'm going to match black to black and red to red. And I apologize in advance for the sound. And now we have a buzzer, right? And if we wanted, we could have a buzzer and a motor and some lights. And I encourage you to play around, or have your kids play around if you're doing this with kids. A wide array of buzzers you can try out, different pitches. Or you might want to hide the buzzers depending on how many kids you have playing with it at a given time. Okay, so this is really getting started with just the basic squishy circuits. I'm going to pull out these LEDs. Now if we wanted to, we can now add the insulating or less conductive dough. So as you noticed, when I put a purple piece of conductive dough across the circuit, the lights turned off, right? And we said that was because it was a short circuit and we were giving another path for the current, a lower resistance path for the current to run through. So I'm going to pop that LED back in. And now I'm going to make that bridge, but I'm going to make it with the white, less conductive or insulating dough. And notice that even though I lay it on, that red light stays on. Okay. Well, what'll happen now is I can actually make a sandwich. I'm going to make a sandwich where I take 2 pieces of purple dough, a piece of my white insulating dough, and I push it together. And the key here when I push it together is the purple dough is never touching. The 2 pieces of purple dough are never touching. This white dough, the insulating dough, is working as a spacer. So now, if I plug my wires back into the purple dough, as I did before, I can build my LED circuits without having to worry about physically keeping the 2 doughs apart by hand. I've got the spacer in there. And when we have that, we can start making other circuits, right? No one said they had to be lines. We just have to make sure that we have a positive piece of dough and a negative dough that are separated and not touching. So a circuit that we like making, our sushi circuit, I'm going to make a little ball, and then I'm going to make 2 snakes, one of conductive dough and one of insulating dough. And I'm going to put the insulating dough snake around the ball. And then I'm going to put a conductive snake around. I'll grab a little more dough to complete that. So we have this. You'll notice, again, we have 2 sections of purple conductive dough, but they're separated by our white insulating dough. So now I'm going to take my battery pack and I'm going to plug in the black wire into, in this case I'll do the outer ring, and on the underneath side here I'll take the red wire and plug that in. And now we can make a wreath, because if we think about the circuit, we've got the current flowing from the battery pack through the red wire, and then through that purple dough there. And then we need some little bridge that'll connect that outside ring to the inside ring. So I'm going to use the LEDs to do that, and I'm going to plug them in. And now we can make a little LED wreath. So we encourage you to play around and try your own circuits and let us know. We'd love to post some pictures on the website if you do something you'd like to share. I will give one little note. As I said, we will do a video where we go into greater depth on the LEDs. But one safety tip we want to point out. First off, we purposely use low voltage. So we here typically don't go above 6 volts or maybe 9 volts, but we would recommend the 4 AA's. The second thing is LEDs can burn out. If you run too much current or voltage through them, they can burn out or, in very rare cases, pop. And they're really the main safety concern we would have with squishy circuits. However, if you put some dough between your battery pack and your LED, this won't be a problem. Because the dough, as we said, isn't really a wire, it's a wire plus a resistor. So it's cutting down on the current. So what I'm going to do is I'm going to put on some safety glasses and show you what would happen if I put my LED directly to the battery packs. And again, I don't recommend that you do this at home. All right, so if we attach it directly to the battery pack, watch the LED because this will go very fast. And you heard that, maybe heard a little hiss and that little flash of light and it burn out. We'll never get this one to light back up again. Let's do that one more time. I'm going to take a different LED. I'm going to attach short end to the black wire and the long end to the red wire. Little flash and it's out and it smells awful here. I'm so glad you can't smell it. Once you burnt them out, you can't use them again. So the key here is never ever put your LEDs directly to your battery pack. Always make sure there's some dough between the battery pack and the LED. So thanks for listening and please feel free to contact us if you have any questions.